So welcome everyone. I'm Michaela van der Schaar, and I'm a professor at the University of Cambridge, currently working on developing new machine learning methods for medicine and healthcare. And the focus of these methods is to really empower clinicians and patients alike. And I'm also leading a center called the Cambridge Center for AI in Medicine. And I've started WeCREATE in March this year with the overall goal of inspiring female students and young professionals to embrace creative careers in engineering, in computer science, in applied maths and beyond. And in the process, dispel widely held myths and establish views about these areas. We want to really emphasize the creative nature of these fields. And in order to do so, we highlight a diverse range of amazing female role models, making their mark on the world. Created for women and is open to all, no one should be discouraged from pursuing AI, machine learning, as well as being part of this ecosystem of engineering, computer science, applied maths, and beyond. In the first two sessions, Famke Kohl helped me moderate these sessions. Unfortunately, she is leaving our center to pursue other endeavors. So I have asked Evgeny Savelyev, our center's machine learning engineering wizard, to take the role of moderator for WeCREATE. And you may wonder why I asked Evgeny to do so. Well, there are two reasons for it. First, as I mentioned, WeCREATE as an open forum to all, not only to women. Second, Evgeny is combining the challenging role of being a machine learning engineer in our interdisciplinary center, building and developing methods that are really empowering clinicians, so going across disciplines. But also he has the equally complex task of being a part-time PhD student. So it is exactly such diverse, complex, non-standard career paths that Evgeny is pursuing that we would also like to highlight as part of our session. With this, Evgeny, the floor is yours.
Thank you, Michaela, for that wonderful introduction. So first of all, everyone, I'll just give a quick overview of the schedule of the session. First, there'll be a quick introduction by Michaela and myself. Then we will do the creative project showcases from our wonderful speakers and a discussion led by Michaela, which is the main part of the session, about 40 minutes. And at the end, we will do a Q&A for about 15 minutes. So everyone, please do think of any questions you might ask. It'll be quite a casual discussion, hopefully. So yeah, anything that you think of, please do drop those questions in the Zoom chat to everyone. Please, that's important logistical bit. And yeah, drop those questions even during the session, not just at the end. And finally, there'll be a wrap-up. Now, I would like to introduce our speakers. We are very delighted to have Professor Chiara Petroli, who's a professor of computer science and engineering at Sapienza University of Rome, where she holds many roles, including Rector for Scouting, Fundraising, and SME Incubation. She has multiple awards, among others, including 100 Women Against the Stereotype in STEM to 2016. And interestingly, she is a CTO and founder of WSense, a spin-off company of Sapienza on the Internet of Underwater Things. We also have Professor Mingyan Liu, who is Professor of Engineering, Chair of Electrical and Computer Engineering, and Professor of Electrical Engineering and Computer Science at the University of Michigan, Ann Arbor. Her most recent research activities involve cyber risk quantification and designing cybersecurity incentive mechanisms. And in 2014, she co-founded a startup company, Quadmetrics, which commercializes predictive data analytics that she developed. And she is a recipient of multiple awards, including Distinguished University Innovator Award 2018. We then have Dr. Emma Slade, who is Senior AI Machine Learning Engineer at GSK AI, who leads a research group in building data-efficient deep learning models in the context of active learning approaches. She holds a DPhil in Theoretical Physics from the University of Oxford and Master of Sciences in Theoretical Physics from UCL, where she was awarded the Kathleen Lonsdale Medal for the top graduating student. And finally, we have Dr. Elizabeth Daly, who is a research scientist at IBM Research Dublin, and she is leading the Interactive AI group. Her team is researching innovative solutions for interactive AI where systems influence users and vice versa. She received a PhD in computer science from Trinity College Dublin, and she is also adjunct assistant professor in the School of Computer Science and Statistics at Trinity College Dublin. She's serving on the Royal Irish Academy Committee on Engineering and Computer Science. So with that, without further ado, let us get into the creative project showcase and discussion led by Professor Michaela van der Schaar.
Thank you so much, Evgeny. So first, I'd like to also thank very much to Chiara, Minian, Emma, and Elizabeth for joining us. And I need to say that I'm really deeply honored to have met quite some time ago both Chiara and Minian. And they became personal friends, and they have been unbelievably inspiring to me personally throughout my career as well. And I was so delighted for all of you that they accepted to be part of the discussion today. So I'd like to start with the two more senior speakers today, Chiara and Minian. Maybe you can tell us a little bit about one of the projects that you are currently working on. Maybe you can start sharing screen, and maybe for 3 to 5 minutes can say something about a project you are interested in. And then I can jump in and ask you a few questions. And then I'm moving to our more junior, but equally brilliant panelists today, Emma and Elizabeth.
Can you see my screen?
Yes, we can.
Okay, so what I want to introduce you to is an area that I'm working on and that I'm really passionate about, is that of providing the big data that Internet of Things and the Internet brought to us in the terrestrial world to the underwater domain. This is what we call the Internet of Underwater Things. And this is at the core, I think, of what has driven me along all my career. I think I decided when I was 22 to enter research doing a PhD because I wanted to maintain, and this is, I think, something we have pretty much in common with Michaela, the ambition to try to change the world and try to use research to innovate and shape the future for good. And I think this is something that also women in research and also in innovation, they really find as something they're interested in and they can provide significant contribution. In particular, among the many things I've been working on Internet of Things, on wireless systems over my career as a researcher, what really got my interest a decade ago was the fact that our planet, as you see in this slide, is covered by water, okay, for most of it, actually 70% of the planet. And we know this part, the part covered by water, less than we know far away planets such as Mars, because we are not able to get there. We are not able to use remote sensing technologies we have developed over the years to be able to see what happens over the water column. We are not able to exchange data as we do with radio communication above water. Radio communication does not work in salty water, it's fast attenuated. So we actually don't have information about this part of the planet, which is so connected to our future, because it is from this part of the planet, and this is what I realized and what actually got my energy, that the food for a growing humankind will come in the next decades. It is from this part of the planet that the energy, resources with renewable energy that will be key for our economy will come. And sadly enough, also the minerals that are at the core of our development and our usual lives will come from this part of the planet. So we have to start well from the very beginning and develop technology that allow us to know and also optimize the process to make them sustainable, to take care about this part of our planet that is so connected to our future. Okay, so this actually led me to start developing novel concept, okay, having something like the Internet of Things for this underwater domain, and things had to be done completely different because we have to use sometimes wireless optical, multi-frequency acoustic, but we have very big challenges on developing communication devices. And this is where somehow machine learning came in. We realized a decade ago in my group that we could not do things. People were trying to measure everything, and actually you had to learn the best way to work when developing underwater wireless mesh network. And we have developed a number of protocol stacks and ideas, and actually bringing this concept into international patents. And this was the starting point of everything since then we have developed to enable exchange of data that today turn into two directions. One is the kind of an underwater mobile infrastructure. So we are providing and developing basically underwater sensor node that can go to deep water and provide a wireless infrastructure for future autonomous robotic resident system for offshore. And the other is the underwater IoT. So underwater sensor networks that using this novel wireless mesh networking can finally provide the real-time in situ continuous monitoring of the underwater environment until a point that typically is on the surface, but not necessary, where we connect to the traditional internet. And these networks are bidirectional. So now we can get rich data, seeing what we cannot see without technology. So the abysses and the water column. And then we can send from remote commands, changing the application logic, changing the sensor we want to activate, how frequently, the land threshold, and so on. So this had to be led because of the same reason that drove me to research, which is the shaping the world, to the fact that several categories of users needing this big data could actually use it. Okay, and I tried to do it in the traditional way. I tried to do it through industry, talking to people, but it was kind of changing the paradigm, and they could not really catch up or follow up. So we decided to do it directly. I had a very talented group of PhDs, and we created the spinoff. And this, in 5 years, grew to 50 people in Italy, Norway, and we have also small location at NOC, University of Southampton. But it's what is most important is that possibly this will be a successful scale up, but every day now we're bringing in larger and larger companies into this concept. And what I'm really proud of this team is that we're changing how we work underwater, the blue column. You see here an example of a bit how an architecture works, but I'm now talking about application. What are we doing with this? We're working with climate change experts, because this is another point. We cannot understand climate change without understanding what's happening from this environment. And we don't even have good data on temperature. We don't have good data on the percentage of CO2. So we are with them studying strategies to increase the percentage of CO2 that can be absorbed underwater. And this is a concrete potential mitigation strategy against climate change. We are giving the environmental monitoring systems to provide, in situ monitoring, structural monitoring of future offshore renewable. We are providing a solution for digitalizing aquaculture and even getting directly fish welfare data from wearables we have developed for fish. And I stop it here, but I can follow up with other example later.
Thanks, Chiara. Minyan?
Hi, everyone. I am absolutely delighted to be here and share with you a few examples of the projects that we're working on. Mihaela said, focus on what's creative. I don't know about creativity, but I thought I would, assuming that this audience more or less has some familiarity with machine learning, I'll show a few machine learning empowered data analytics project we have that uses data that is not commonly studied. And, in the AI domain, you'll see a lot of research on facial recognition, image data, vision processing. This is a very different type of data, as is, I would say, Mihaela's healthcare information, right? So the first thing I want to highlight has to do with internet scanning, which you just saw Chiara presented these pictures of the Earth, the globe, right? We have remote imaging techniques to come up with these global maps. We have similarly billions and billions of devices connected to the internet. We similarly need a way to map out that connectivity. What are these devices that are connected to the internet? Each one of you are right now sitting in front of one and possibly more devices as we speak. And this mapping is usually done by what's called internet scanning. It's basically distributed computer programs that pings machines that are live. And not only they do it once, they do it thousands of times, because each machine that you're sitting in front of has many, many thousands of ports. And by doing this type of pinging, handshake, and depending on how the machine responds, you can figure out, you can infer what type of machine it is, the version number of the software that's running. Is it a web server, or is it an end host? Is it an IoT device, et cetera, et cetera. And it has enormous amount of application in terms of cybersecurity, the internet growth, topological studies, any number of things. And this is usually done exhaustively, meaning that the computer program is just going to exhaustively scan all the IPv4 addresses there are, okay? And it's bandwidth consuming and time consuming. And what I'm showing here is how a project we did that is trying to make this smarter, okay? And for those of you who are familiar with variational autoencoders, this is nothing more than an application of that. But for this type of projects, the amount of work and creativity is often lies in front end, is the data processing, because the data is not readily available for you to plug in. So what we built is essentially a compressor, and what we call host-to-vec. If you're familiar with the notion word-to-vec, then this is a pun on that. Basically mapping each internet host into a vector using this type of deep learning method. And once you compress that, you can enable any number of downstream applications like detecting or forecasting malicious hosts. Just to give you an idea of how effective this can be, you take the compressed numerical vector, and if you project it onto 2 dimension, and if you just color them based on country of origin, which you see here is a clear concentration. And what this concentration shows is the compressed vector retains huge amount of the original information. So internet scan data is heavily compressible. Here's another image colored by server type. You can see the concentration. So these representations are completely numerical now. It does not look in any way like the original scan data, but information is retained. So here's one example of using deep learning methods in a domain where I think there's a lot remain to be explored. Another, continuing on, you can use similar type, and actually this doesn't even involve deep learning, just standard supervised learning. We used a random forest to actually pair the scan data, feature data, with data breach reports to enable supervised learning. And this is an example result of what you can do in terms of predicting material data breaches. And we can do that fairly accurately if you look at the false positive versus true positive. And this is the technology we were able to successfully commercialize. We essentially, using this, built the world's first global scale enterprise security rating system. One area that's being used is in underwriting cyber insurance policies. You all carry various insurance policies. Cyber insurance is a fast growing area. One thing they don't have compared to other traditional areas is the underlying risk is often unobservable, and there lacks actuarial tools and statistical historical data, statistical models for the underwriter on the right-hand side to accurately assess the risk of the client who's on the left-hand side. And the tools we developed essentially fills this gap as a proxy or as actuarial information to help risk quantification. One thing that we are currently working on is how to underwrite, how to do risk assessment and underwrite this type of policy for ransomware type of data breaches. It's a fascinating area that involves an active participant, which is the attacker, unlike in a lot of other data breach scenarios. So I'm going to stop here and give it back to Mihaela.
Thank you, Chiara and Minian. Well, before we go to Emma and Elizabeth, maybe it's time to ask a few questions from my side to the two of you. I'm going to start with kind of a simple one, and I want to ask you to keep your answers as brief as you possibly can. What made you, Minian, become an engineer, and you, Chiara, become a computer scientist? Again.
Okay, it's very simple. My favorite subject in high school was physics. When it came time to apply for college, everybody told me there are no jobs in physics. So the closest thing to physics was electrical engineering, and that's what I did.
Wonderful. Chiara, it makes Emma smile because she studied physics. So we will ask her opinion on that in a little bit. But Chiara, why computer science?
Yes, when I was 18, I have to say that I was a bit confused. What I knew is that I liked two things. Okay, I liked math, and I actually liked solving problems. These were the two things. But I also liked art. This is also true for my son. So somehow it's a combination in the family. So I was unsure.
The art of math is computer science.
Art of math is computer science. And actually, it could have been engineering. It could have been math. It could be computer science. So among these three, it was a bit random, my selection. But what I really liked from the very beginning out of computer science, computer engineering, is that it really gives you the tools, okay, that you can use to solve a lot of big challenges. And this is exactly what I wanted to do.
Thank you. Let me ask both of you, Evgeny read part of your very successful bios, but the reality is that both of you are successful academics at two very impressive institutions. You are successful entrepreneurs, and both of you have been leaders in your departments. So Minian was department head of a very big department at the University of Michigan. You, Chiara, now have a vice president role, vice dean and chancellor role. How do you both achieve this? What made you become entrepreneurs? What made you decide to take the complex job of being in a more leading position, also in the academic environment, which is complex? Can you share your experience and also some advice about this journey with our audience? Chiara, maybe you start and then we move to Minian to alternate.
Yes, so in general, I think that when I entered the university, I've always been curious, and maybe it's almost a kind of a need for me to also test myself in different things. So from even when I was an assistant professor, I was trying to understand how the university was working, was in the academic senate, for instance, and so on. And this is, you know, I kept doing, okay, I kept doing also in the international serving in roles for the international scientific community and so on. So I was interested in two things. Of course, I directed labs because I was interested in innovating. And also, I always found very rewarding, and that is associated to the university, training young researchers towards being able to innovate and think out of the box. So this is the first part of the answer. For me, being an innovative entrepreneur, so having started a spin-off, a deep tech, is completely in line with the same reason why I chose to do research. I would not do it just to do it. I did it because I had results that I think could be a game-changing, and I wanted to bring it to real life, and I couldn't find any other way. So this is completely in line with what I have always done in my whole life. And the same thing is related to training to out-of-the-box thinker, because it's a deep tech full of PhD. We have 1/3 of the people, I have a PhD, and it's training them to push forward what is possible. As for the academic career, I think you feel that when you kind of develop your skills, you know, you follow your careers, you want to give back. And you also develop pushing there and there, but in all this, you know, strategic thinking. Okay, so what I wanted to give back was my experiences, you know, so that also others could actually follow the same path, and possibly this is exactly what I'm doing right now. So I'm lucky enough that for some periods I can contribute to put together, you know, a structure so that others can innovate, have a successful startup, can learn from the experience. So we are developing entrepreneurial traineeship that we can provide to all students. At Sapienza, we have over 100,000 students. Think about how much you can change the world. Basically training them to innovate, training them to do deep tech and so on. So it's all connected to the ultimate drives I'm trying to follow in my life.
Wonderful. Thank you, Chiara. Minyan.
So I think for me, a couple things that's probably echo what Chiara just said. I think it's very important to always be gaining new experiences and learning new things. I think that's a very important part of, I think, our both physical and mental health. The sense of that I'm doing something new, and so because of that, I always kept an open mind. I know, you know, especially when I'm on panels for women, I always get this question about, we need to be careful what we say yes to. Otherwise, we'll be inundated with requests to do this and that. And then you have panels that are titled How to Say No, right? So I was on one of these panels and I felt like, I'm not sure I ever said no to anything. Now, I'm sure there are things I did say no. Those are things that you've done it, you know, it's repetitive. You're not going to learn anything new. But even those things, sometimes I say yes because the service is needed, right? And you never know who, maybe the new person you're going to meet on a committee this time. And so I really do want to say, I'm not sure we should always say no or be careful of saying yes. I think if the opportunity appeals to you and you think you're going to learn something, or you think the service you're doing is an important one, say yes, because life is full of unexpected turns and twists. We have no way to anticipate what each opportunity is going to lead you down to. You say no because you say, well, this is only going to tax my already taxed schedule. I'm not going to gain anything out of it. Well, the truth is you cannot know that for a fact, right? We don't have perfect information. And so I think embracing opportunity is an important part of my journey. Entrepreneurial endeavor, I never imagined I would actually have a company, because Mihaela knows me, my work is mostly pen and paper, right? We do exercises in theory, it's all hypothetical. So I never imagined, but this was an opportunity that I felt there may be actually a chance. And like Chiara said, sometimes if you want to make the impact, you actually have to do it yourself. You cannot count on other people to carry through your vision. So that was that. And in terms of the chair's position, again, there was an opportunity, and it was clear to me I could play a role. I'm very service-minded. I benefited enormously from good citizens, good, institutional support. And so it was clear to my mind that I have something to pay back, if I can serve the community, that was my chance to do so. Thank you.
Thank you very much, Chiara and Minyan. Final question, in view of time, I want to ask you just 1 minute answer for it. I know it's probably a question you can talk a lot about, but what now you have achieved, it seems to me, a lot of everything. What are your plans for the future? What's next? What would you like to achieve still and do? 1 minute, please. Minyan.
Well, what I just said was I keep an open mind, which basically means I don't actually have a plan. I still have active research. We are doing some exciting things, and I'm sure Mihaela will hear more from me on that. And that's one of the things that excites me the most. You know, sometimes a student gets stuck for month and month, and then one day the sky clears up. You know, I really enjoy those moments. So I think whatever else I do, research is going to be remain an active part of what I do.
Chiara?
For me, in the short term, I'm possibly more attracted towards scaling up in this phase of my life in the next couple of years, my company, because I really think that it's a time where we can change the blue economy, enabling the big data that are needed for the scientists to know and understand, for for the companies that we will be developing energy, for our infrastructure to be safe. How you want, this is really the key turning point where it's possible to change the world with this. And very fascinating, by the way, problems, multidisciplinary optimization problems coming out of it. So what can I say? That it's really interesting, and it's what I want to do with a challenging task to force this directly or indirectly to become the way the world we live. So this is what
Thank you so much, Chiara and Minyan. It's now time to go to very successful but more junior females who I know a little less, but who I met through different endeavors, and I was very inspired by them, by their energy and by their own vision. So Emma and Elizabeth, the floor is yours to present briefly one project you are working on that you are interested in and excited about and highlights the creativity. Emma, maybe you start and then Elizabeth.
Sure.
Sure.
Yeah, so I obviously have only kind of started my career compared to Minyan and Chiara. So I wanted to just talk a little bit about my research team that I run at GSK. So I work in the AI group at GSK. So we do artificial intelligence research focused on healthcare, like Mihaela does. And as Evgeny said in the introduction, I work on something called active learning. So I basically just wanted to very briefly, in a couple of slides, tell you what active learning is. So it's quite a simple question in a way. The idea is what we want to do is take some AI model. So it can be a very simple random forest or support vector machine, something like that, all the way up to some super complicated deep learning model. And we want to maximize the performance of that model while annotating the fewest data points possible. So what that means is, with the least amount of data, what's the best we can do with this model? And the reason I work on this is because, as you can probably imagine, this is very important to industry, and in particular, it's very important to the pharmaceutical sector. And this is because the data that we use is often very, very expensive to obtain. And it's very, very expensive to label. And by expensive, I mean, it can take a lot of time to get this data, but also it can be physically a costly endeavor to obtain data. So you might have to actually pay a doctor to go and label points of the data. You might have to pay a pathologist to go and take an image of a huge tissue and label parts of the tissue. And ultimately, in terms of the human cost, we're working with people who have illnesses, and we want to basically probe them as little as possible in order to be able to make good predictions about the illness they may have. So on the top right-hand corner, I've got the sum total of the group that I have. So I've got 3 postdocs, one of whom starting on Monday, in fact, Christian, and then I have an open position for an engineer as well. So currently 3 + 1 is the size of my group. And the research that we do for active learning tries to answer, in effect, a couple of main questions. So the existing frameworks that do this active learning and try and understand how to make AI models as good as possible with the least amount of data are subject to huge amounts of bias and error and uncertainty, and that, they cherry pick this and they cherry pick that. We want to get rid of all of that. We want to do active learning in a kind of agnostic manner. We're working with very important data. We want to be able to make predictions we can trust. We want to make predictions clinicians can trust. We want to make predictions that geneticists can trust. We're working with very, very important data sets. So the research we do is to try and build these active learning models to help the teams within GSK build their models, which are interacting directly with biologists at different stages of the drug discovery pipeline, without all these biases and errors and uncertainties in them. And as Michaela said, I'm quite a junior, so this is stuff I've actually only been doing since January, the research group I have. I've been at GSK a couple of years, but I've pivoted away from graph neural networks into active learning as of this year. So the results of my research group so far are one paper, which is my paper. The postdocs hadn't started yet. But what we did is we had a proof of concept. So we showed that we can do this. We can build these really data efficient models using a really novel bias-free, or less bias, not bias-free, nothing's bias-free. But we can build a task agnostic model for doing active learning, where we can get rid of a lot of these biases and a lot of these errors and assumptions that go into previous frameworks, and we can beat them. So we can be more efficient than they are, and we can be quicker than they are. And so that's kind of a stepping stone to then scaling up this research. And that's why we've now got a small group doing very fun applications of this initial framework that I built out. So we've got you, Karen and Christian, who are going to be doing very, very fun research on different applications of active learning. So that's my...
Thank you so much, Emma. Elizabeth.
So my name is Elizabeth Daly, and I'm a senior technical staff member and research scientist in the Dublin Research Lab. And I have been in IBM, it's going to be 15 years in 2 days, I've been told. And I've been a part of the research lab, which opened just over 10 years ago. And one of the projects I got to work on a couple of years ago, which was quite application based. It was trying to improve the AI pipeline for sales opportunities inside the organization. And so we went and built all these machine learning models to try and predict, should we send an opportunity to this part of the division or this part of the division? Or can we predict this opportunity is going to be won or it's going to be lost? And while I wouldn't say that those were necessarily really easy, they turned out to be really just the beginning part of the challenge. And that's what I found really fascinating. So that work really led me to 2 research questions that have driven the last 2 years of work, which is how do you convince stakeholders to deploy AI technologies? It's one thing for us to show an accuracy measure, but how can they really trust it? How can they know it's something that they can deploy in the real world solutions? And then really importantly, how do you correct and influence the model based on your expertise? Because the data, your model is only as good as the data that you're trained on. And that only is one particular view of the world. To top it off, it might be a model that needs to be able to act in a changing set of rules and policies. So in the sales world, it could be that an opportunity above 5K needed to be sent one direction and one above 10K needed to be sent another direction. And your historical data is no longer reflective of what were the rules that were in place at the time. So you need to be able to change it. So we started working on a pipeline in order to be able to address this. And it made me really start to focus on being able to say that if you truly want to be able to leverage automation, which was part of the challenge here, you must address the challenges of designing AI systems where users are fundamentally able to understand, control, and trust the system that's being put in place. So we started to put together a pipeline of tools that are designed to work together in order to be able to tackle some of these problems. So the first is transparency. So being able to take potentially a machine learning model, very inspired by work by Michaela, and being able to translate them into a transparent machine learning, a transparent rule-based model. And once you have this transparent rule-based model, there's a couple of different things you can do with it. One, if you feel you really trust it, you can go and make that your model and make that something that you're going to act upon. Or you can use it as something to run in parallel and say, well, I trust those rules, but there's going to be exceptional circumstances that the machine learning model is telling me to do something different. So show me those instances and maybe use it to debug the system. And importantly, we can use it to allow a user create a mental model of what their machine learning model is doing. And once you have an idea on what your machine learning model is doing, you have the ability to potentially correct it. So we've been looking at using the rule-based model as a mechanism to elicit feedback from the user, because once you see the rules and you don't agree with them anymore, you can then potentially correct them. So in our case, when we had that problem where we had end users who were not necessarily going to be machine learning experts had feedback, and they said, well, it's no longer going to be 5K that rule applies to, it's going to be 10K. And also we have a new geography that we need to be able to support. And you know what, we can treat that as similar to the UK. And so be able to give that feedback in the form of Boolean clauses. And then importantly, governance. So once you've made those changes, how can you say that you understand what changes have really taken place? Because accuracy alone is not going to be a reflection of that. And so we designed a visual mechanism that also uses these rule-based mechanisms to show where the rules overlap or differ from the new model versus the previous model. And we also then built a solution that can be employed inside the organization, where you can upload your machine learning predictions and use it to create these rules and then provide the feedback into the underlying machine learning model. And for me, that's where we've been focused on for the last 2 years.
Wonderful. Thank you so much, Elizabeth and Emma. I have a few questions for you. So the first one is, why the two of you decided to work for industry and both of you for somewhat larger companies? What has inspired you to do so? Elizabeth, maybe
Sure.
I start with you, since you have slightly more experience than Emma.
So when I finished my PhD, I felt I wanted to be able to focus on doing work where I was able to collaborate with senior peers, and I really felt I was at a stage where I wanted to understand some industry problems. After spending some time kind of searching for research questions and problems, I really appreciated the opportunity to see how people were using AI technologies and let that drive some of the directions that I worked in. So I found that quite empowering.
Wonderful. Emma?
For me, I think when I was doing my PhD, so I did very, very theoretical physics. But some of what I did was doing relatively simple machine learning on modeling the structure of the proton. And as you can imagine, the data for modeling the structure of the proton is very complicated. And I realized what I found interesting was trying to understand really, really complex data sets with cool computational methods. And I'm quite fortunate in that the biotech sector has kind of exploded in the last few years. And so there was this opportunity to go work for GSK, so a big pharmaceutical company who have huge amounts of very cool, complex data, and they wanted people to come and do cool machine learning on it. And it was kind of like the ideal thing for me to go and do research in machine learning with very complex data. So it wasn't so much choice if I wanted to leave physics, it's just I found what was actually really interesting to me within the little niche I was working in.
I have one more question for both of you. What are your big ambitions for the near future and maybe for the longer future? But just very briefly, such that I end and give the floor to our participants. So what are your ambitions for the near and maybe slightly near future? Just very briefly. Emma?
I don't know. I want to do impactful research. I think near future, again, working in pharma, things take a long time for results to come to fruition. So for me, the near future is I want to do impactful, interesting machine learning research and make an academic contribution to the field.
Wonderful. Elizabeth?
So I think one of the things I enjoy as being a research manager as well as a researcher is that it's not just that I think about my own research interests and expertise. I have to really take the time to understand the expertise and the interests of the people in my team. And I really enjoy figuring out how to bring it together in a way that they're solving a problem that they wouldn't have been able to if they hadn't worked together. One of the things I like about our lab is we have people with very different backgrounds and skill sets. And I really feel I like to play a role of bridging between those worlds sometimes and getting everyone to use their skills in an interesting way.
I so resonate with you, Elizabeth. Yes. Evgeny, I think now it's time for you to moderate the audience questions, to ask our panelists their questions. Thank you very much, Chiara, Minian, Elizabeth, and Emma.
Yeah, fantastic. We have quite a few questions. If anyone else has questions, still a chance to drop them in the Zoom chat. But first, let us take a question from Sanja, or maybe Sanja, sorry if I can pronounce it. I know you've kind of already answered this in the chat, Nian, but it would be good to have this on video. So yeah, Sanja, if you could unmute yourself, ask your question, and then the panelists will respond.
Oh, thanks, Evgeny. Though I have to say my question is a little bit more technical. Maybe I missed that the point should also be to think from the female perspective in these technical fields. But okay, my question was because I was really inspired by Mingyan's presentation. So she was using some models. I was wondering, has she tried something of more recent deep graph Infomax type of models? And also because this was very like on a large scale, I was wondering about detecting malicious hosts, which is super important nowadays.
Thank you for the question, Sanja. So yeah, so to your first point, we have not. And I think it's an interesting idea. I think it depends on whether deep graph informatics type of models require connectivity information, which is not part of the data. These are individual scan information. But that's an interesting idea. To your second question, yes, we have, as I showed on the right-hand side box, downstream applications. Detecting malicious hosts is very much part of that. And we have been able to show that you can do it very accurately, not just detection, but also prediction.
Okay, thank you, everyone. Now, let us take a question for Chiara. This one's actually from myself. So I'd be very interested to hear what the experience was like for you to branch out into the world of spin-off and startup from academia, because I think it can be quite different.
Yes, I think one of the key points is completely different. Managing a company and leading a research lab, a research group. But I think in general, when you want to increase your abilities or your knowledge, something I always found very useful is that you have to be humble. You need to know what you don't know and try to get it from experts or more knowledgeable people. I think this is in general, absorbing from everyone, listening to everyone is in general useful for any career, also as a researcher. So one of the important points is that we started knowing that we were not business, people with business professionals with experience on how to manage a company. So I kind of asked for help and kind of got people who trained being part of the project with us, trained the team to learn. And of course, the PhD students that got a PhD and that are part in the R&D, they learned how to do it in a more structured way, innovate. And I learned from managers or from people with an experience like CEO of big companies, how they were doing things. And of course, I have my view, and I'm still focusing on innovation that we have been able to structure based on the company that had this experience. So you have to try to go with people who can help filling the gap and learn from them.
Thank you very much. That's very insightful. Thank you. And we have now a couple more questions. So let us have the question for Emma from Rita.
Yeah, thank you everyone for the presentation. So it's really great. And I actually wanted to ask Emma a little bit more about the approach that she was using for active learning and how exactly you estimated uncertainty, because I just felt like it's a really interesting approach and would be happy to learn a little bit more about it.
Sure, thanks. Yeah, so what we actually do is we use reinforcement learning. So in reinforcement learning, you have an agent taking actions or making decisions in some environment. So what we do is we take the active learning procedure and we cast it in the form of a reinforcement learning problem. So the agent is picking data points in some representation of the space of data and some high dimensional representation of the data. And the agent, because it's a meta-learning problem, is allowed to determine for itself how it chooses the data points. So one of the inputs the agent considers is how uncertain it is about the data. So for that, we just use a Shannon entropy. It's quite a standard way of determining uncertainty of data points, but it's not the only thing the agent takes into consideration when it's deciding what points to label for the model to use.
Thank you.
Evgeny, I see there is one more question here, but I see the participant has left. There's a question from Anna, so maybe I can read it. It's a question for Minyan, but I guess it could be for Minyan or Chiara. You mentioned that sometimes you have to rely on not to rely on others, but do it yourself. Do you think there are equal opportunities in funding, I assume, startups for women? Minyan and Chiara.
So there are two types of fundings, right? So here in the United States, there is the government funding for venture endeavors. So things like SBIR, many funding agencies who do give out these seed grant like money for translational tech transfer type of work. I would like to think that those types of opportunities are you know, they're fair game, although I have to say that I was not successful in applying to one of those simply because we were just starting out. We had no track record. What I am seeing is agencies like the National Science Foundation increasingly providing additional supplemental funding for transition to practice, and those have been helpful. In terms of venture funding, so interestingly, we actually did not pursue that route. I think anecdotally, I have heard there is significant gender bias. That's what I heard in terms of venture capital, to the point that there are collectives that are specifically aiming at supporting female entrepreneurs. So I think the reality is there. I think there are opportunity. I don't think it is a gender even playing ground.
Okay.
Yes, if I can add, it is true. It is known in the European level, but I think it's even internationally that there is an issue related to what is the percentage of VC money, so venture capital money, going to female-led, female only in terms of management. I think get only 2% of the VC money. I will speak about 11% in case of an hybrid management. So there is a big issue, and I'm going everywhere, basically telling that when the government funds VC should impose this not to happen. Okay, so I was in a FAO, Food Agriculture Organization, a few years ago, and I was actually reinforcing this for that kind of sector. I'm doing it because it's important. But on the other hand, think about it. If you want to be a successful entrepreneur, you will have a lot of different kind of problems. And resilience, okay, is an important quality. It is also, if you want to successfully develop a career in a highly competitive environment, including research. So as a female, I think there are two tricks, if I can give an advice. One is never think that you cannot do something, okay? Simply try. If you can relax and try, you will discover that you can do much more than you think. The second is to be resilient. Accept that no one will understand that you can do more than others, because, for instance, with VC, it is also quantitative data and evidence that actually female-led achieve more results despite this, things sometimes don't go how it should be. But if you build your resilience, then you will become much more powerful. And actually, these are the game-changing female leadership of the future that I hope we are stimulating today.
If I may add to that, I completely agree. I think I want to absolutely emphasize, just because the field is not level, should not discourage you from pursue your passion and your dream. The one thing I want to add is you just have to have superior ideas, better ideas. And I know collectively we do, okay? As long as your ideas are superior, you will get the opportunity and the funding.
Fantastic. Thank you, everyone, for a great discussion. We will have now, I think, a final question in view of time. Sonia, you have a question for Emma and or Elizabeth, or both. If you could go ahead with that one, please.
Thanks a lot. Yes, so this question is less technical and more about females being leaders. So I guess both of your contexts are male dominated, as far as I can guess. So I'm wondering, how does it be to be a young woman leader? Does it require a special type of confidence? If you can comment on any challenges and how you tackled them.
So there was something that Chiara said that really resonated with me, which was don't be afraid to not know something. And I think it's easy to mistake that for a weakness, but actually I would argue it's a bravery, and it's actually one of your strengths in the end, being able to say you don't know something. And when it comes to this confidence question, one thing that I always say to myself, which I heard from another person, is never compare your inner self with someone else's external self. It might look like the people you see are super confident and they think they rock, but they might not always feel that way. But you know, that's okay. That's also part of our skill set. And one thing I will say, it's taken me a while to come to believe this, but I feel your combination of expertise and experiences means you probably have a unique point of view, and that point of view might be exactly the thing that the problem needs. And so you might be able to solve the problem in a different way because you don't know some of the things that the other people in the room know. So I think it's turning that might be perceived as a weakness into a strength, actually.
Anything to add at all?
Sure. Yeah, I'm obviously in an extremely male-dominated field. I think for me, having role models is really important. And that can be female role models, but obviously there may be an issue where there aren't really female role models in your company, or someone you can connect with, or for whatever reason there may not be a woman you can kind of connect with in that way. And so there's no reason, I think, to not kind of model yourself on male higher up figures who you view as being excellent managers or excellent scientists. And as someone who's moved from university physics realm into industry biotech realm, there's a phenomenal difference in how women are treated compared to when I was a physicist. It sucked. It was awful. I now really enjoy my time being in the healthcare sector, being in AI. And so the role models I have are mostly men, because that's who most of the people in the field are, but they are people I want to be like. They're the people I want to model myself as a manager or model myself as a researcher. So just because you're in an extremely male-dominated field doesn't mean you can't look up to the men who are successful.
Thank you, Emma. Thank you, everyone. I think this is all the questions we'll cover today. I will now just do a quick wrap up at the end of the session. Just a few informational kind of things. The next WeCREATE session, we are planning it in December. We do this about once in 3 months or so. You will be able to get the information on the mailing list or on our website, and we record these sessions and we put them on YouTube as well, so that people can view them later. And the Schaar Lab channel is where this will go. And when this session is recorded and live on YouTube, there'll be an email distributed as well with a direct link to that. Finally, you know, we'd like everyone to get involved as much as possible in WeCREATE. So please do send us ideas for future sessions or anything like that. Of course, you can subscribe to the mailing list on the website. You can join as a WeCREATE ambassador. You can view our existing ambassadors on the website as well, so to get even more involved. So please have a look at the website. And of course, also please do spread the word and let your friends, colleagues, and your network know. Most important things, the website is WeCREATE.academy, quite simple. The email address that we use has changed slightly. If you were involved in previous sessions, it's now vanderschaarlab@damp.cam.ac.uk. That's such a different one, so sorry for it. So changes there. So I think that is it.
Well, if you allow me, Evgeny, to thank again very much to Chiara, Minyan, Elizabeth, and Emma for the fantastic session. I enjoyed so much just hearing them, listening to them, and at times I felt, oh, I so resonate with what has been said, and at times I've learned new things. So thank you all very much for sharing your precious time with everyone else.
Thank you to our speakers and thank you to our wonderful audience, and we will hope to see you again in the next session.